Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into a crucial aspect of operating systems, their design and implementation. Sheila, why don't you kick us off with the importance of this topic?
Absolutely, Victor. The design and implementation of an operating system are foundational to its success. It's like architecting and building a city. Every decision impacts how efficiently and effectively it will function. Today, we'll explore the key principles that guide OS designers and developers in creating robust, efficient, and user-friendly systems.
Great analogy, Sheila. Let's start with the fundamental question. What are the primary goals when designing an operating system?
Well, Victor, there are several key objectives. First and foremost is defining the system's purpose. Is it for general-purpose computing, real-time operations, or embedded systems? This dictates many subsequent design choices. Additionally, designers aim for ease of use, flexibility, reliability, and, increasingly important in today's world, security and privacy.
Those are crucial considerations, Sheila. It's interesting how these goals can sometimes conflict with each other. For instance, a highly secure system might sacrifice some ease of use. This leads us to an important concept in OS design: the separation of policy and mechanism. Can you elaborate on this?
Certainly. The separation of policy and mechanism is a fundamental principle in OS design. Policy refers to what will be done, while mechanism is how it will be done. For example, in process scheduling, the policy might be to prioritize interactive processes, while the mechanism is the actual algorithm that implements this policy.
That's a great explanation. Why is this separation so important?
It's crucial for flexibility and modularity, Victor. By separating policy from mechanism, we can change policies without altering the underlying mechanisms. This makes the OS more adaptable to different use cases and easier to maintain and upgrade. Think of it like a car's engine management system. You can adjust the driving mode, policy, without changing the engine's core operations, mechanism.
Excellent point, Sheila. Now, let's move on to implementation techniques. What are some key approaches used in developing operating systems?
Implementation techniques have evolved significantly over time, Victor. Historically, operating systems were written in assembly language for maximum control and efficiency. However, this made them difficult to port to different hardware and challenging to maintain. Modern OS development typically uses a combination of high-level languages like C or C++ for most of the system, with assembly used only for the most hardware-specific parts.
That's fascinating. It reminds me of the transition from early OSes like MS-DOS to more modern systems like Linux or Windows. Speaking of which, how do programming languages impact OS development?
Great question. The choice of programming language significantly influences the development process and the resulting system. C remains popular due to its low-level capabilities and efficiency. It allows direct memory manipulation and close hardware interaction, which are crucial for OS development. However, some newer OSes or components are experimenting with languages like Rust, which offers memory safety without sacrificing performance.
Interesting. Are there any drawbacks to using higher-level languages in OS development?
While higher-level languages can improve productivity and reduce certain types of errors, they may introduce overhead. This can impact performance, which is critical in an OS. Also, some high-level language features like garbage collection can be problematic in an OS context where precise control over resource management is necessary. It's all about finding the right balance between development efficiency, system performance, and maintainability.
That makes sense. It seems like OS design and implementation is a field full of trade-offs and careful decision-making. As we wrap up, what would you say are the key takeaways for our listeners, especially if they were preparing for an interview on this topic?
Great question, Victor. I'd emphasize these points. 1. Understand the primary goals of OS design: purpose, efficiency, flexibility, reliability, and security. 2. Recognize the importance of separating policy from mechanism for adaptability and maintainability. 3. Be aware of the evolution of implementation techniques, from assembly to high-level languages. 4. Understand the trade-offs in choosing programming languages for OS development, balancing control, efficiency, and development productivity. 5. Appreciate that OS design is about making informed decisions based on specific requirements and constraints.
Excellent summary, Sheila. It's clear that OS design and implementation is a complex field that requires a deep understanding of both hardware and software principles. For our listeners, remember that these concepts form the foundation of every operating system you interact with daily.
Absolutely, Victor. And for those preparing for interviews, being able to discuss these principles and their implications will demonstrate a solid grasp of OS fundamentals. It's not just about knowing the what, but understanding the why behind design decisions.
Well said, Sheila. That wraps up our discussion on operating system design and implementation. Thanks to all our listeners for tuning in to Operating Systems Crashcast. Until next time, keep exploring the fascinating world of operating systems.